Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. In this lecture, we are going to see conversion of binary number into decimal number. So we know the traditional way of doing conversion. Here I am going to introduce a shortcut to you. Now see what is the traditional method. If you are having, so single zero you know it is a 0 only, single 1 you know it is a 1 only. Now if I will give you 1 0 or 1 1, you need to convert. How we used to do? Since this is the last point, last digit, least significant bit, it will power its weight is going to the 0, it's 2 to the power 1. Now how you used to do? 0 into 2 to the power 0 plus 1 into 2 to the power 1. Whatever number you are having, with that you are going to multiply the weightage. So here you are going to get 0. Here you are going to get 1 into 2, 2. So this number, the decimal of that, you are going to get 2. Similarly for 1, 1, how you used to do? So here the power is, so 1 into 2 to the power 1 for this, plus 1 into 2 to the power 0. So 1 into 2 plus 1 into 1. Anything to the power 0, you know that it is going to be 0. So it is 2 plus 1 equal to 3. So this is one way. Again, if you will take 1, 1, 1 and again 1. So this 0 to the 0, to the 1, to the 2, to the power 3 like this. So to the 3 into 1 plus to the 2 into 1 plus to the 1 into 1 plus to the 0 into 1. So this is a traditional way that we used to do in our college, and even in, if you are from CBSE background, in class 11, 12 we used to do like that. Now 1. So in school also we used to do like that. So it's 10 and 15. So decimal equivalent of that is going to your 15. So this is a traditional way. Now I am going to introduce a shortcut way. Whichever you will feel comfortable, you can use. What I am going to do now, see, to the first bit you need to multiply with the base of that number. So decimal number, you know that. This is a binary number. Binary number base, you know that it is a 2, base 2. So you will multiply it 2 into 1 plus the next bit you are having, you will add it. So 2 into 1 is 2 plus 1. So you are going to get 3. See, you got 3. What I am doing, to the first bit you need to multiply with the base, then you add the next bit. Now if it is having 2 bit, then you are going to do like this. Now if you are having more than 2 bit, like assume you are having 3, 1. What you will do, to the first bit you will multiply with 2, you did it. Then add with the next bit, so you got 3. Now to the result, again you multiply with the base. So you multiply with the base, again you add plus 1. So it's 6 plus 1, 7. See, you got it. So this, see, I am explaining, so I am taking time. If you do fast, you will get the answer very quickly. See here. So here how we will do? First I will multiply. So now I am going to use the shortcut method here. So first what I will do? 2 into 1 this, then plus this. So 3. Now with the resultant I will multiply with 2. Then next bit I will plus. So I will get 7. Now to the resultant I will multiply with 2 and next bit I will plus. So you will get 50. When you are going to stop, when there is no other bit to add. Now see, 7 into 2 did, now next bit you are going to add is 1. Now 15 you got the result. Now there is no other bit to add. If in 1, 1, 1, you know that it is now 15. If I add 0 here, now how you will get the answer for this kind of question? See, so 15 you know that this is 15. What you will do? You will do into 2 plus 0. See, 30. So this way you can give the decimal equivalent of that very quickly, because if you know this 101 and they are given 111 like this, so you know that 101 is 5. So 5 into 2, then plus 1, you will get 11. 11 into 2 plus 1 for this, you will get 22. Then plus 1, 23. See, then into 2 plus 1. So 6, 4 plus 1, 47. So this way, if you know that the result of some bit earlier, so you know at least 3 bit everyone know. So you know that that is going to 5. Then since this is base 2 number, you will multiply with the base, then add the next bit. Now with the resultant, multiply with the 2 and add the next bit. Now resultant multiply with 2 means multiply with the base. Since it is a binary number, that's why I am multiplying with 2. If I will take ternary number, then I will multiply with 3. If I will take any other number system with the base, see that number base is 2 because it's a binary number. I am converting binary into decimal. If you convert ternary into decimal, then 3 into 3. Okay. So whatever will be the base, I will multiply. So it is like how I am doing. If you are having some number like this, if it is having base b and you append a either 0 or 1, something you append. Okay, let us assume you append a. So let us assume the result of that number is r in decimal. So it will be r into b plus a. So the number will be, if it is having 101 or anything, let us assume its decimal equivalent is r and its base system is b. So r into b you will do, then append plus a. So that number you are going to get a decimal number. So see, this way if you will do, you will get the answer very quickly. I have written the procedure for you. So procedure is saying that we multiply the first bit with base and add with the next bit, and then with the result we multiply it with base and add the next bit, and stop when we are going to stop when there is no bit to add. Okay, so this is the procedure I have written, so you can write it down in your note. Now if the base of the number system is n, so if you are having a base 10 number system like decimal, so how many symbols you are having? 10. What are the symbols? 0 to n minus 1, that is 10 minus 1, 9. So for if it is a binary number, so its base is 2. So how many symbols you are having? 2. What are the symbols? 0 to 2 minus 1, 1. Okay, so it has n symbols. Whatever will be the base, that many symbols you are going to have, and it will be 0 to n minus 1. For octal, 8, base 8, see 0 to 7 symbols are there, means 0, 1, 2 till 7.